All right, in the last example, we were looking at 3x3 systems, and you had two of them that we worked out together. This video is to include some additional practice with 3 more 3x3 systems and to ensure that the last video didn't get too crazy long. If you already did these on your own, this video can showcase kind of a different approach, or maybe it'll cement your learning. So let's take a look at this first one. So because I have a z here, actually let's zoom in a little bit more here. Because I have a z there that doesn't have a coefficient, that's a big indication that I'll probably want to get rid of the z's. So I'm going to go ahead and select the first two equations, and we're going to call this a. And so now for my a values, let's go ahead and have 2x minus 5y minus 6z equals 57. And then my second one, which is negative 4x plus 7y minus z equals 19. Now because that top one is a negative 6, we're going to multiply that bottom one by negative 6. So I'm going to multiply by negative 6 because I want the z to become a positive, so that when I multiply out that 6, I end up with a positive 6 so that they can cancel out. So I have 2x minus 5y minus 6z equals 57. On the bottom here, a negative times a negative is a positive, so I end up with 24x. And then 7 times negative 6, that's going to give me a negative 42y. And then I'll have a positive 6z, and then that's going to equal a negative 114. So now looking here, our z's cancel out, and so when we combine this 24 and 2, that's going to give me 26x, negative 5y minus 42, that's going to give me a negative 47y, and then that's going to equal negative 57. Alright, so from here, we have our equation that we were looking for, highlighted in gray. Now let's look at our b equations. So here again, because of that z that has no coefficient, I'm going to select the next two, and then we're going to call this b. So for our b, we're going to go ahead and rewrite that top equation, so negative 4x plus 7y minus z equals 19. That bottom equation gives us that 9x minus y plus 4z equals negative 45. So this top one, because of that 4, I want to multiply that top one by positive 4. So when I multiply that, I end up with negative 16x plus 28y minus 4z equals 76. In that bottom, I end up with 9x minus y plus 4z equals negative 75 all over. Sorry, not all over, but we're going to go ahead and combine these two. So we end up with our z's going away. So 16x plus 9x, that's going to give me a negative 7x. 28y minus y, that's going to give me a positive 27y. Our z's are gone. 76 minus 75, that gives me a 1. So here is our next equation. Alright, so now we're going to combine these two stored equations to get rid of another variable. And do notice that some of these are a little bit larger, but here we go. So in combining those two, I'm going to have 26x minus 47y equals negative 57. And then my bottom equation is going to be negative x plus 27y equals 1. Now let's go ahead and get rid of the x variable. And so because 26 and 27 don't really have anything in common, I'm going to have to multiply that top equation by 7. Now I'll multiply that bottom equation by positive 26. So when in doing that, then I'm going to end up with 7 times 26x. That's going to give me 182x. Okay. And then I'm going to end up subtracting 7 times 47y, which is going to give me a 329y. And 7 times negative 57, that's going to be a negative 399. In that denominator, 26 times negative 7, that's going to be a negative 182x. And then that's going to be plus 26 times 27, that's 702y. And that equals 26 times 1, which is 26. These are gone, so I get 329y plus 702y. That gives me 373y. And that negative 399 plus that 26, that's going to give me a negative 373. I'm going to divide both of these numbers by 373, and I end up with y equals negative 1. So there's our first value, sorry. It's our first value. And so now that I have my first value, I'm going to come back to these starred equations, and I'm going to pick one to plug in my y into in order to get the other one. So I'm going to go ahead and use this one just because it has a smaller value. So negative 7x plus 27 negative 1 times negative 1 equals 1. So negative 7x minus 27 equals 1. I'm going to add 27 to both sides, so negative 7x equals 28. Divide both sides by negative 7, and I end up with x equals negative 4. Alright. Our last case is, now that I have two of these, I'm going to go back to one of the main ones here, and I'm going to pick one of these equations to plug in. So I'm just going to go ahead and pick that first one. So I'm going to end up with 2 times negative 4 minus 5 times y, which is negative 1, minus 6z equals 57. Okay. 2 times negative 4, that gives me negative 8 plus 5 minus 6z equals 57. Negative 8 plus 5, that's going to give me a negative 3 minus 6z equals 57. I'm going to go ahead and add 3 to both sides, so I get negative 6z equals 60. So I end up with z equals negative 10. So then our point here is going to be negative 4, negative 1, negative 10. All right, let's move on to the next one. So in this particular one, notice that there's different ways that we can approach it. Again, our goal is to eliminate the 3 by 3, turn it into a 2 by 2, and then solve for one of the variables. We can go with y or we can go with z here, only because this leading coefficient has a 1, this y value has a 1 too, so it's up to you how you decide to do it. I'm going to go ahead and select these two equations to be my first one. So I'm going to have a, and I'm going to have 4x minus 5y plus z equals 20. And then I have 6x minus y minus 2z equals 35. So in looking at this, I apologize about that. I don't know what's going on with my tablet here, but so I'm going to go ahead and select this top one, and because I have a z there, I'm going to go ahead and multiply by 2. When I multiply by 2, I get a positive 2z, and I have a minus 2z there, so that will allow those to cancel out. So let's see what we get here. So now I'm going to have 8x minus 10y plus 2z equals 40. And then I'm going to have 6x minus y minus 2z equals 35. So here we can see that the z's cancel out. They're gone. And so I'm left with, oops, there we go. 8x plus 6x, that's going to give us a 14x. Negative 10y minus y, that's going to give me a negative 11y. And then this is going to equal 40 plus 35, which is a 75. So this is my next equation to compare. And so now for b, I'm going to go ahead and do this top one and this bottom one for b. Again, noticing that I can go ahead and cancel out those z's. So now I have 4x from that top equation minus 5y plus z equals 20. And in that bottom equation, I'm going to end up with negative 2x plus 8y minus 3z equals negative 9. So again, I want to cancel out that z, so we're going to go ahead and multiply that top equation by 3, and then I end up with 12x minus 15y plus 3z equals 60. So then I have negative 2x on the bottom plus 8y, again just rewriting that last equation. So when we combine both of these, our z's are gone, they cancel out. So I'm left with 60 minus 9, which gives me a negative 51. It's actually positive. Negative 15y plus 8y, that gives me a negative 7y. 12x minus 2x, that gives me 10x. Here's our second equation. We're going to combine both of those equations, so I end up with 14x minus 11y equals 75. 10x minus 7y equals 51. And so here we have a choice of which one to eliminate again. And neither one of these is going to give us a nice elimination. But if we notice, if I multiply the top equation, all right, I'm going to try to get rid of x here. So I can, in order to get rid of y, I would have to multiply the bottom equation by 11, multiply that top equation by 7. So again, resulting in some pretty decently large numbers. But notice that if I look at 14 and 10, both of them actually are multiplied to 70. So I just need to multiply that top equation by 5. And then that bottom equation, I'm going to go ahead and multiply it by negative 7. So in doing so, I'm still going to end up with some large numbers, but they're not going to be as large as if I eliminated the y. It's your choice. You can eliminate the y if you want. So in multiplication, I'm going to end up with 70x on the top minus 55y equals 375. On that bottom, I'm going to end up with negative 70x. Remember, because we're multiplying out that negative, it's going to be plus 49y. And that's going to equal negative 357. Notice our x's are gone. Now negative 55y plus 49y, that gives me a negative 6y, which 375 minus 357, that's going to give me 18. Divide both sides by negative 6, and I end up with y equals negative 3. Alright, our last one, so now we're going to end up with, now that we have our y value, we're going to pick one. Remember, it's going to be one of our 2 by 2s that we're going to plug y into. So here we had 14 times, whoops, I don't know what's going on with my pen. Actually, let's do 10. So we're going to have 10x minus 7. And I only switched because these numbers are a little bit smaller. And so 7 times negative 3, so I end up with 10x minus plus 21 equals 51. Subtract both sides by 21, I get 10x. 10x is equal to 30. Divide by both sides by 10, I end up with x equals 3. Once I have x, I'm now going to go back to the original system, 3 by 3 system, and select one to plug in x and y into. So I'm going to have 4 times 3 minus 5 times negative 3 plus z. So I'm picking that first equation there, equals 20. 4 times 3 is 12 plus 15. I don't know why my stylus writes that way sometimes. 15 plus 12, sorry, is going to give us 27 plus z equals 20. Subtract both sides by 27, so we get z equals negative 7. So then we see that our answers are going to be 3, negative 3, and negative 7. It's our unique solution. Alright, the last example here on this page is number 5 here. And the cool thing about this example is notice that that first one is already in a 2 by 2, right? So I have x and I have z. This tells me that I don't have a choice. I have to eliminate y. And actually, if we look at these, notice that these also only have 2 variables. I have x and y and z. So I could actually eliminate any one of them, but it's going to be a shorter process the way that I look at this. So let's take a look at this. We can decide which one we want to get rid of. I am going to go ahead and get rid of y. And so in doing so, I'm going to use the bottom 2 equations and call that A. So here's A. Notice those bottom two equations have a y in common. So that top equation is going to be 4x plus 3y. It's helpful to write a spacer, so I'm just going to do 0z equals to negative 31. All right, in that next lane, notice I don't have an x, so this is going to be called 0x, right, plus 3y, so now this is going to be negative 7y minus 2z equals 73. So, oh, why did that write so funny? There it goes. All right, because I'm getting rid of y, I am going to have to multiply both of these equations by a different number. So I'm going to take that top equation, I'm going to multiply it by 7. Take this bottom equation and multiply it by 3. I don't need to do a sign change because of the fact that that bottom one is negative. So I'm going to go ahead and multiply this out. So I end up with, let's just change colors here, let's go back to black. We're going to have 28x plus 21y sorry, my stylus is not cooperating here, plus 0z, so notice that that one doesn't change, and then negative 31 times 7 is going to give us a negative 217. Alright class, sorry about that. It seems like my stylus was having a hard time. But once we got this equation here, what we're going to do is we're going to find the next one. So I need to use, so I have 28x minus 6z equals 2, so I need to get rid of the z's and the x. So I come back to this equation, notice that it's just 8x minus z. So that's how I got this equation here. So here's my 8x minus z equals 7. And I'm going to rewrite my yellow equation over here. So I have 28x minus 6z equals positive 2. So here I want to be able to get rid of the x, and luckily this x has no coefficient. So I'm just going to multiply it by negative 6. I choose negative 6 so that it could turn into a positive 6. Looks like my stylus is writing a little bit better now. So I end up with, I multiply this through, I end up with negative 48x plus 6z equals negative 42. Rewrite that second equation, 28x minus 6z equals 2. Combine my terms here, so notice that the 6's go away, and I'm left with negative 48 plus 28x, which gives me a 20x, negative 42 plus 2, which gives me a 40. Divide by 20 on both sides, and we're left with x equals 2. So that's our x value here. And now we're going to go ahead and plug it in. So I'm going to take this equation, our equation 8x minus z equals 7, and I'm going to plug in x equals 2. So I have 8 times 2, which gives us a 16, minus z equals 7, so I have that subtraction of the z, and that equals 7. So now I'm going to go ahead and move the 16 over. So I end up with 7 minus 16, so I get z equals negative 9. Okay, and so this should have been a negative 9. And so now I'm left with finding out what that y value is. So I go back to my original equations, and I'm going to go ahead, and the one that I selected was this one right here. I could have selected the last one if I wanted to. So I'm going to go ahead and plug it in. So I know that x equals 2, so I plugged in the 2. 4 times 2 gives me 8, plus 3y equals negative 31. 8 plus 3y equals negative 31. I subtract 8 from both sides. I end up with negative 39. And then I'm going to divide by 3, so I end up with negative 13 as my answer. So our final solution then is going to be x is 2, y is negative 13, and our z of negative 9. It looks like my stylus is back to writing. So that's the end of this, and so this one was pretty fun to do just because it is technically two variables per equation, but overall the system has 3 variables, 3 equations, which allowed us to solve it. Alright, hope you had fun with that one too. Bye!